Hi there, this is Sajadullah and this is my IoT Node.js and BLE assignment demo video. So we'll start by what is Node.js. Now, Node.js is the JavaScript runtime environment which is based on Google's V8 engine. It just basically allows us to run JavaScript. The Node.js application runs only on a single thread, but using asynchronous code, we can have callback functions. This can allow us to run multiple blocks of code on a single thread. We're also using BLE here. So BLE is a low power consumption. It's very easy to connect and set up, and it enables the transfer of low amounts of data. We're going to be using GAP and GAT in the BLE. So GAP defines the general topology of the Bluetooth Low Energy network stack, and GAT describes in detail how the attributes such as data are transferred once the devices have a dedicated connection. Now, the project task was to develop a system using a gateway communicating with an end device over Bluetooth Low Energy. So we're going to be using a Raspberry Pi and BBC Microbit to achieve this. So the sensor that we're going to use is the SCD30 sensor, which has a CO2 sensor. This sensor was chosen because it can detect 400 to 10,000 parts per million with an accuracy up to plus or minus 30 parts per million. This is the architecture of the setup or our project. So up here we have the BBC Microbit connected to the CO2. It's going to be communicating via Bluetooth Low Energy to the Raspberry Pi, which itself is running Node.js gateway code. And then this is going to be communicating with Hive MQ. So this is going to be running the MQTT cloud broker. Now inside this MQTT, we're going to be having two topics. One of the topics is going to be a CO2/publish topic. So this is where we're going to publish the CO2 sensor values in hex. The other topic that we're going to have is the CO2 /subscribe topic. This is where we are going to be checking for the off command to turn off the LED matrix. Now we're going to show our demo video. Now this video doesn't go full screen, so we'll just use the video that we already have loaded up. So here we are, we've logged into Hive MQ, and we have already subscribed to the two topics, CO2 /publish and CO2 /subscribe. Oh yeah, I should also show that over here. So this is our connection over here. So we are running the BBC Microbit connected to the CO2 sensor, and here's our Raspberry Pi. So that's what's running down here below the screen a little bit there. So we've just turned on the Raspberry Pi, opened up a new terminal. We're going to clear the terminal here, so whatever that is. And now we're going to run the Node.js code. So down here it is discovering the device and it's getting the device name. It's printing out the services. So some text over here that's already displaying. It's saying publish values from Microbit will appear here in the CO2 publish topic. So over here it's publishing to the MQTT, and here message is published to topic CO2 /publish. Over here it has published it, so it said CO2 value in hex is this over here. So the CO2 value has to be extracted from this hex value. So there's our Microbit running the code. So there's another one. So it does this every 5 seconds. It prints out the CO2 hex value. So I guess we'll just show how the hex value is extracted from this value. So the CO2 hex value, we don't care about the first two hex values. We use the next four. So over here, the next four is 0300. So if you want to find out what the hex value is, the CO2 value in the room is we convert 0300 to a decimal. So the CO2 in the room is 768 parts per million. Now we're going to go back into the video. So now we'll start typing in commands to the subscribe. So there it's publishing every 5 seconds. Now we're typing in just any random message. We've just typed in hello and we've published it. It's showing up there, and it's also showing up over here. Received message is hello on topic. So the command received from MQTT broker was not an off command. That's just showing the user that this is not the command to turn off the LED. But now we will enter in an off command. So we're going to put an off. We're going to publish it. And when we publish, it says over here, command received from MQTT broker to turn LED off. So that's gonna down here. It's turned off the LED down here. So if we watch when we type that in, if we watch down here, the smiley face, the unhappy face just turns off there. So there, it's turned off there as soon as we press that, as soon as we published it. And then it goes back to publishing the CO2 value. So the LED matrix is off, but it's still reading the CO2 values there. So that's working all as it should be. We do have a little bit of an error here about an unhandled promises rejection. So we did fix this later on, and I'll just show you the code that we used to fix it later. So that's the code there, and we do see that the publish and subscribe are all working as they should. And we're just restarting this CO2 BBC Microbit just to turn back on the LED. So there, now it's going to be displaying the values up again. The matrix is going to be redisplaying the values. Published values is going to be showing up here in CO2 publish. And it's publishing again. So that's all there working as intended. So we'll just show you the code now. We've opened up the code in Microsoft Visual Studio, and we'll just talk through it. So the very first line of code, we'll just talk about this up here first though. So the environmental variable that we are using is the CO2 sensor, and it's working on the microbit using the LED matrix to display a happy emoji face if CO2 levels are below a set threshold, example 600 parts per million. If it is above the threshold, it will display an unhappy emoji face. So the very first line of code that we're using requires the MQTT module. So we're saving this into a variable called MQTT. So whenever we're using anything related to MQTT, we just use this. So we're connecting into the MQTT dashboard, and we're defining our topic to publish to and topic to subscribe to. So this is the two topics that we subscribe to in the video. Over here, we are defining the device of interest. So this is the device of interest of our BLE. This is the service of interest. This is the UUID of the CO2 service. And then this is the UUID of the read and write characteristic of the CO2 service. Down here is all the event handlers. So when the MQTT connects, it's going to call this function connection callback. So it's going to print out to the console, it's connected to the MQTT cloud broker. So it's going to subscribe to the topic, and it's also going to publish over here. So publish values from MQTT will appear here a lot, and then call back the push callback. Push callback will only run, so if there's an error happening there, it's gonna let us know, and then if there isn't, it's going to say it's subscribed to and waiting messages on top. So as I showed you there, we did have an error over here. So the error was over here. The error was an unhandled promises rejection warning, and this was later fixed. So this was the old code that was giving this error, and then this was later fixed using rewriting it to use a catch to handle rejections. So now this works perfectly fine. So it works over here. So we don't get an error anymore after this. So over here, so command received from MQTT broker to turn LED off, and then the error pops up. But then after we run the updated code, command received from MQTT To turn LED off, it shows this error instead. So rejection occurred at a message event handler. So that's how we fixed it. So the event handler will simply check the received message on the topic. If it's off, then it's going to print out an acknowledgement that the message is an off message, and then it's going to write an off to the CO2 write characteristic. Or else if it's not an off command, then it's just going to print out command received was not an off command. So this is the function write data back callback error. This function is called. It checks if the data cannot be written to. So we'll just skip down here to the main code over here. So this is the entry point to the application. Over here, it requires the Bluetooth module to connect to the Bluetooth. It's getting available Bluetooth adapter. It's starting the discovery process, and it's going to get the Bluetooth device. So it's going to get the device name, and then it's going to print it out to the console. It's going to stop discovering, and then it's going to look for the specific device that we have defined up at the very top over here. So it's going to just get the device name. It's just going to print all that information out to the terminal. It's going to stop discovering. It's going to connect it. It's going to display get the GATT services and then display them to the user. And then we're just using while one to loop this bit of code indefinitely. So we're using promises to delay for 5 seconds, just to slow down the rate it shows up at the terminal, so we can read it every 5 seconds. If services include the primary service of interest, so this is the UUID of the service of interest, so this is the CO2. We just print out a little console log message. And then we're going to get the primary services of the UUID. We're going to get the characteristics, just print out the characteristic flags. So this will print out if it's a read and a write. And it's going to save the value. So it's going to read it and save it to cval here. It's going to print out to the terminal publishing to MQTT. And it's going to use MQTT client.publish to publish to the topic. So it's going to publish in this format. So CO2 value hex is going to print the hex value in string, and it's going to call the push callback function as well. And it's going to do done publishing.